Now that we have learned a little bit about two types of variability, we're going to do a little bit more practice with the second one that we learned in the previous lesson, called the mean absolute deviation, also known as the MAD. And again, this is a measure of variability, how changeable a data set is, how consistent or inconsistent it is. The more variable, the less consistent it is. We also had another measure of variability called the interquartile range, also known as the IQR, which was another measure of variability. So these are the two measures of variability that we're going to consider. And just like the mean, median, and mode can be used to talk about kind of where the center of a data set is, MAD and the IQR are two ways of determining variability in a data set. So we can reference both of them. So I'm going to take a look at group number 1 down below here. So the problem is that there are two data sets below. Each set represents the number of errors on a typing test for a group of students. I know when I was in high school, I started a typing class, but I think I didn't finish it. I think I transferred into something else. So I never really learned how to type, which was a real bummer when I got to college and I had to do papers that were 10, 20 pages, and I didn't really know how to type very well. So if you get a chance to either take a class or just do an app or program to learn to type and type well, then I recommend it. Okay, we're going to do group number 1, and I'm going to leave group number 2 for you. And so group number 1 down here, we're going to be calculating the interquartile range and the mean absolute deviation for the first group. And so we're going to start with the interquartile range. And the interquartile range, remember, we have to get the quartiles. In other words, we have to do what's called the 5-number summary, or at least the quartiles in the 5-number summary, which requires us to first find the median. And of course, when you're getting a median, you need those numbers in order from least to greatest. We were nice and gave you numbers in order from least to greatest. You're welcome. So there are 10 numbers here, which means that the median is going to fall between the middle two. It's the average of the middle two. Well, 9 and 9, the average of 9 and 9 is still just going to be 9, right? So we have that. Then we're going to go ahead and find the median of the first half of the data, which is going to be our Q1. There are 5 numbers here, so the middle number in this case is one of the numbers, and that is our lower quartile. Q1 is 8. Do the same thing with the upper half. 5 numbers there. The middle of those numbers is that second 10. So that's our third quartile, or Q3. And that's all we need for that, because to find the interquartile range, I simply subtract the upper quartile and the lower quartile, which gives us 2. So that is a measure of variability. Seems like a rather low number, which will tell us maybe something about how changeable that data is. Let's see what the MAD gives us for variability here. So the MAD is the mean absolute deviation. That requires a little bit more work, and we've organized with a table a little bit here to help you out with that. At some point you might be asked to do it without having a table provided. You can certainly always make one, but let's go ahead and first put in our data values. So 5, 6, there's a couple 8s, there's a couple 9s, there are 3 10s, and for whatever reason the formatting when I kicked it over here kicked that last row to the next page, so let's just don't worry about that and just add 11 to the bottom. Okay, so we're going to average. Remember, the MAD is basically the average distance that the numbers are away from the mean, so the average distance away from the mean. And so we got to average up those numbers. And so if you add them up, you think you get 86. And so we're going to take 86 divided by how many numbers there are. There's 10, and we know that that is 8.6. Move that decimal point over one spot to the left when you're dividing by 10. Now this is a little tedious, but we're going to write 8.6 all the way down here just so we can make our visual math a little bit easier. So we're just going to put that mean all the way down here. So we're going to find the distance the data value is away from the mean. To find a distance, we're going to start off by subtracting. So 5 minus 8.6. is negative 3.6 because 5 is lower than the mean, so it's on the left side of the mean. 6 minus 8.6 is negative 2.6. That's also below the mean. Next one, negative 0.6. Next couple are negative 0.6. And then we have some numbers that are higher than the mean. 9 minus 8.6 is 0.4. 0.4 again. 1.4, 1.4, 1.4, and 2.4. Now, I wore my Stay Positive t-shirt today with an absolute value symbol as a pun. Love puns. So I'm glad that we're working on absolute value today with the absolute deviation. So we're going to take the absolute value, which means just take the distance away from 0. How far away is negative 3.6 from 0? Well, it's 3.6 units away from 0. So an absolute value just changes everything to positive because it thinks of it as a distance. So everything turns to positive. If it already is positive, then it just stays positive. And those are all the distances then. So this is like the distance from the mean. And we're going to average those together now because the mean absolute deviation means the mean of the absolute deviations. These are the absolute deviations. So the mean of those, we're going to average them together. The sum of those is 14.8. I can do that quick mental math. And we're going to divide by 10 because there are 10 numbers. 14.8 divided by 10 is 1.48. So that is the mean absolute deviation. Also kind of a smaller number, which again kind of tells us something about the variability being a little smaller. So I'm going to have you guys, though, now go on with the second group up here and do the same sort of calculations, the IQR and the MAD for that, and provided a table for you to have some help there. And then number 3 asks you to discuss the variability of the typing errors by referencing the IQR and MAD. So think about what the interquartile range and MAD are for each one of the data sets and think about which one is more variable, which one's less variable. How do you know that one is more or less variable? Give the evidence of that. Okay, so you guys can now go ahead and do number 2 and 3. And